Welcome in everyone. In this video I'm going to go over some coordinate plane basics, including basic plotting and coordinate reading, and finding the midpoint between 2 points and the distance between 2 points. Let's get into it. Before we get into plotting points on a coordinate plane or reading the coordinates of a point, it's a good idea to have a basic knowledge of what the coordinate plane is. A coordinate plane is made up of two different axes, which is the plural for the word axis. We have the x-axis, which is the horizontal axis here on the coordinate plane, and we have a y-axis, sometimes known as the f of x axis, and that is the vertical axis here. And there's a very important point on the coordinate plane called the origin, where everything begins. And it is where the two axes cross. So right here where this O is, this is the origin point. All right, so we have the origin. We understand what the x and y axis are and what they look like. The only other thing I want to go over here are the number of quadrants these axes create. So as you can see, the horizontal and vertical axis divide the plane into 4 equal parts, which we call the quadrants. In quadrant 1, the coordinates are all positive. So we'll have one positive coordinate and another positive coordinate. In quadrant 2, the first coordinate will be negative and the second coordinate will be positive. In the third quadrant, both coordinates will be negative, and in the fourth quadrant, the first will be positive and the second will be negative. Before I move on to the next slide, I want to circle back and revisit this origin point. The origin point, I've already said, is where the two axes cross. But with this, we can also put values to it. We can give it an ordered pair right now. So just sort of implicitly, I've given you the facts that ordered pairs need to have two values. The first value and the second value. We're going to go over more than that on the next slide. But what you'll notice is the first values here and here, as long as we are in the first quadrant, are both positive, moving to the right. If you look at the first coordinates over here, moving to the left, they're both negative. Well, this origin is right on this line, so we did not move right at all, and we did not move left at all. So that means this value can't be positive, and it cannot be negative. There's only one number that fits that description, and it is 0. And if you look at the second coordinate here, we have positive coordinates above the x-axis, and we have negative coordinates below the x-axis. So the second coordinate here, we did not move above, so the second coordinate cannot be positive. We did not move below the x-axis, so it cannot be negative. Again, we have to have a number that is neither positive nor negative, which we've already gone over with the first coordinate, is 0. So the origin has coordinates 0, 0, and that is really important because when we start graphing ordered pairs or trying to identify the coordinates of a point, we will be starting from the origin every single time at 0, 0. To give some more context for coordinates being positive and negative, we're just going to start graphing some points or some ordered pairs here. So we're going to graph the following. Point A, and yes, points are generally represented with capital letters here. Point A seems to be at 5, 3. Now, just from what you've seen on the last slide, both of these coordinates are positive, so this point should be graphed somewhere in the first quadrant. But where in the first quadrant? Well, what we need to understand before we do any graphing is that the first coordinate represents the x value on the coordinate plane, and the second coordinate represents the y value on the coordinate plane. And when you have this knowledge, then you can start plotting ordered pairs as points on the coordinate plane. So what we do from here is we notice that x value is 5 and the y value is 3. So as long as we can plot a single point somewhere over here in the first quadrant that has an x value of 5 and a y value of 3, we're in the right place. So starting from the origin, as you remember, this is 0, 0. The x-axis you can see being horizontal, we will move 5 in the horizontal direction. Now we've already talked about it. To the right is positive numbers, so we'll move to the right, positive 5. And with the y values from the origin, positive numbers are up and negative numbers are down. So we'll have to follow both directions at once. So 5 on the x-axis and up 3 on the y-axis. So it looks like our ordered pair should be right about there. All right. And I'm going to go ahead and label this point A. And if you're feeling fancy, you can write 5, 3 next to it. And in fact, in this situation, since the point didn't land on a nice crosshair, I'll say, where a vertical and a horizontal line meet, it would be a really good idea to label it. That way you can tell everyone where that point is exactly. All right, and we can do the same thing for the next ordered pair here. So we will have to find the value of 7 on the x-axis and a value of -9 on the y-axis. So it looks like we will have to go to the right again, because that's where positive numbers are from the origin for the x's. And then once we get over to positive 7, we will have to go down 9, because that's where the negative y values are. So right about there. All right, and again, that ordered pair, or that point, is not on a vertical and horizontal line where they cross. So it's not there, it's not there, it's right in the middle. It would be a really good idea to just make sure that it is labeled so that we can let everybody know exactly where that point is. So there's your little tutorial on how to graph points. But how do you identify the coordinates of a given point that was already on the graph? So they just popped up here. We've got C, D, and a rogue point E. All right. So let's see if we can identify the coordinates of point C. So again, we're just going to start from the origin like we did when we were trying to get a point plotted on the coordinate plane. Except we're going to start at the origin and then just travel a path using only horizontal and vertical movements to get to the point. So it looks like from the origin, we move to the left 4, and we know horizontal movements are x related. So this is left 4, so the x coordinate will be -4. And then from there, we're going to move down to this level, which I can see has a y value of -8. So the y coordinate here is -8. And those are the coordinates of point C. And we can do something similar for D here. We start at the origin. You can see that we will have to move left 2 to get to point D. But from there, we don't move up to positive y values and we don't move down to negative y values. We stay right in between positive and negative at the y value of 0. So the x coordinate was -2 and the y coordinate here is 0. And anytime you have a point that is on an axis, either the x-axis or the y-axis, you will have a coordinate of 0 somewhere. Like for example, with point E, we don't have to move left or right at all. We just stay right there, which means the x coordinate for this ordered pair would be 0. Now the y coordinate for this ordered pair is a little bit different. We're going to have to count up. You can see here that every 2 blocks is jumping by 4, so we're jumping by 2s for every block. 2, 4, 6, 8, 10. 12. This seems to be right in between, just go with it, I know it's not perfect. This seems to be right in between 10 and 12. So the y coordinate here should be 11. From plotting points to some interesting information about a couple of points on a coordinate plane, we can find the midpoint between 2 points and the distance between 2 points. And you've heard me say the midpoint and distance between 2 points. You must have 2 points for either formula. And so we're looking at point A having these coordinates and point B having these coordinates. Now these little numbers down here, just for context, mean they're coming from different ordered pairs, all right? So this is what I would call maybe ordered pair number 1. This one might be called ordered pair number 2, just a couple different ways to think about it. So the midpoint formula finds averages, and I want to point this out here. Midpoint. We are still finding another point, another ordered pair. So when you're looking for a midpoint, you'd better give coordinate pair, coordinates, okay? And we're just finding averages. So what we're really doing is we're taking the x coordinate from the first point and the x coordinate from the second point, adding them together and dividing by 2. So x coordinate, add them together, divide by 2. And we do the same thing for the y coordinates. All right, the next formula here is the distance formula, and this honestly uses the Pythagorean theorem, and that might not make sense to you at the moment. I'm going to go over this in pictures on the next slide, but the distance would be equal to the square root of all of this stuff. Oof. Instead of adding the x coordinates, we're going to subtract them and then square it. Instead of adding the y values, we're going to subtract them and then square it. And then we will add those two values together, take the square root, and get a distance. Okay, the midpoint formula and the distance formula in pictures. Here's what this looks like. If we were to connect these two points on the coordinate plane here, and then divide that line exactly in half, we would find a midpoint somewhere along the way. So how do we do that? It helps to have a visual representation of what you're trying to find. And so there's the line drawn between them, and what we'll end up doing is finding the halfway point along this line between these 2 points. We first have to identify the coordinates of these points, so let's do that really quick. There we go. From here, we can use the midpoint formula. We can say that this is x sub 1 and y sub 1, and this is x sub 2 and y sub 2. And from here, we can think of it a couple different ways. We can think of it visually, just here, and maybe we can just think of it more logically and just ask the question, what is the middle value between -4 and +2 x's? So we could think of it like this, like how far are these 2 points away from each other horizontally? Well, if we start at -4 and we just count 1, 2, 3, 4, 5, 6, so they're 6 units apart from each other. That means the midpoint here, just between this x value and this x value, is 3, right? Half of 6 is 3. So if we just go over 1, 2, 3, the midpoint should be right above that, like right there. And we can do the same thing for the y's. Let's see, the y's, we start at -4, we go up 2, 4, 6, 8, 9. Oh, okay, so that's an odd number, but what's half of 9? It would be 4.5, so we would have to go up 4 and a little bit, right? 4 and a little bit, yep, that looks like that's going to be the midpoint. Let's see if we can prove this mathematically really quickly. So to jump ahead a little bit, I brought the midpoint formula from the last slide here, and then I substituted the values in for x sub 1 and y sub 1 from this point here, and x sub 2, y sub 2 in this point here. Then all we have to do is simplify. Negative 4 plus 2 is negative 2. All of that divided by 2 is negative 1. Oops. There we go. And the negative 4 plus 5 is 1. 1 divided by 2 is just 1/2. So here we're going to have the ordered pair, negative 1 comma 1/2. So what we can do is just come on over to this graph, find negative 1 where it crosses the line right about there. And yeah, it looks like it's going to be about half a unit up. Remember, half of a block is 1 unit in the vertical direction. And yeah, that's the midpoint. We'll call it M. There it is. Cool. Now, what we're going to do is try to find the distance. And I said on the previous slide that this is closely enough related to the Pythagorean theorem. And here's why. Between these 2 points, A and B, you can see I drew a line in between them. It wasn't there to begin with, but just to help visualize it, there it is. If we make the other legs of a triangle, but it's horizontal and vertical, it forms a right triangle. And with the right triangle, we are able to relate the 3 legs of this triangle, right? It's a squared plus b squared equals c squared. But since we're trying to find the distance, we don't want c squared. We would have taken the square root of both sides. So that's how the Pythagorean theorem plays into this. So how would we figure this out? So let's get the square root. Let me get the distance formula up here. What is it? X sub 1 and y sub 1 minus x sub 2 and y sub 2 parentheses squared plus parentheses squared. And maybe I break it down just a little bit more. You can see how we have 3 quantities being squared. This squared plus this squared equals the hypotenuse squared from the good old Pythagorean theorem. What this does, this x sub 1 minus x sub 2, is what it does is it allows us to find the distance, the horizontal distance between point A and point B. So for example, we know x sub 1, just like in the midpoint above, is negative 4, and x sub 2 is 2. So we'll have numbers in there like that. And y sub 1 is also negative 4, and y sub 2 is 5. And we're subtracting those. All right. From there, we can simplify this, and we can simplify this. So negative 4 minus 2 is going to be negative 6, and negative 4 minus 5 will be negative 9. Squared, squared. So I'm just going to keep leaving this as d squared, so maybe you can see why we have to take the square root of both sides here in just a moment. And you might also be wondering, like, hey, negative 6. Negative 6 isn't a distance. Distances are always positive. You're right. Distances are always positive. However, if you notice that we are squaring this negative value, a negative value being squared will end up being positive. So it doesn't matter if you end up with the positive of this number or the negative of this number. When you square it, it'll end up being the same thing, right? What I mean to say is negative 6 squared is the same thing as positive 6 squared, and the same thing for the 9. So the squaring is what allows us to have a, quote, negative distance. All right, So from there, negative 6 squared is 36, negative 9 squared is 81, and this is d squared. But see, still, this is the distance squared. We don't want the distance squared, so I'm going to take a couple steps at the same time here. I'm going to take the square root of both sides. We'll just end up with d equals square root, and I'm going to add these values together. That is 117. And then, of course, you want to check to see if 117 can be broken down or simplified, and in this case, it can. Once you simplify it, you'll end up with 3 square root of 13, because you can break this down to be 9 times 13 and then take the square root of 9 to get the 3. So there's the distance between A and B. For the last example in this video, I'm going to ask you to find the midpoint in distance between these 2 points. And it's exactly like what we did on the last slide, but without the graph. So I urge you to pause the video as soon as you can and try this on your own. And I will slowly release some steps up as the video progresses. And there you have it. Hopefully you got both of these answers. A very quick run through. Substitute for the midpoint. Substitute x sub 1 and x sub 2 in their correct spaces, and y sub 1 and y sub 2 into their correct spaces. Simplify the numerator of each fraction. Adding these 2 negative numbers keeps it negative, so it'll be negative 7. Adding these 2 negative numbers is like saying 19 minus 1, which is 18. Simplify any fractions that you can. For the distance formula over here, again, substitute x sub 1 and x sub 2 into their correct places, y sub 1 and y sub 2 into their correct places. Simplify the subtractions. That was originally a subtraction in here, but when you subtract a negative, it's the same as addition. So negative 5 plus 2 is negative 3. 19 minus negative 1 is 19 plus positive 1 is 20. Square these numbers, add them together, see if the square root simplifies. In this case, it does not. I hope this video helps you out a lot. See you in the next one.